Alright guys, so here in this tutorial I'm going to teach you about the Python Timeit library. So what is the Timeit library used for? Well, whenever you create algorithms or any other code that actually depends on time, okay, something that you want to measure, how fast it executes, how fast it completes its task. Whenever you create something like this, you want to know how fast it's really going, right? You want to measure its performance. And you typically do this by measuring its execution time, right? Now, some people may use the date time library. What they do is basically find the time before the function or whatever was run, and then they find the time after it was completed, and they subtract that time to find the execution time. Okay, now that's one way of doing it, but that's not very accurate and it doesn't have much support. Okay, it's just a very crude way of doing it. The proper method that we have in Python is through the use of the Timeit library. Okay, you don't need some kind of special software or anything. You just need a single line to actually get the software. To get this library. Okay, you just need to get the Timeit library right here. Okay, import Timeit. Okay, now basically what I'm doing here, I actually have the code for the quicksort algorithm. Okay, and the bubble sort algorithm. These two are actually sorting algorithms. Okay, that sort arrays and sort lists of numbers. Okay, now of course this is actually a very common way of using Timeit, okay, to measure algorithms, right? So I just have these two right here so we can use them as placeholders, okay, and we can see which one's faster. All right, so that's what we're going to do. Okay, basically we're going to use Timeit to measure these two algorithms and find out which one can sort an array faster. Alright, so let's do that. Okay, so the first thing to do is actually create some functions. Okay, again, there are a few different ways of actually doing this. Okay, but this is just the approach I'm taking. Okay, I'm going to create this one function called test1. Then I'm going to create this variable called setup code. Okay, just ignore that. Alright, now basically we have is equal to, and I create a multi-line string. Well, what am I doing here? Don't worry, I'll explain all this. Now what we're going to do here is actually import this function right here, quick sort. Okay, that's the name of our first sort. It's called quick sort. Okay, and then I also want to be using the random library. Okay, so I'm going to include that import in here, and then random. Okay, from random I want to import the randint function. Okay, now what have I done here? Okay, now look, just pretend like all of this is a separate program. Okay, pretend like it's not in this file. Imagine that it's in a separate file somewhere else. Okay, we don't need to think about it. Now basically what I'm doing here is that I want to import, okay, I want to import the quicksort function and import random, okay, into the setup code variable, okay, which is basically a multi-line string. Okay, now again, just imagine that this isn't in this file. Okay, imagine the quicksort function is in some other file. Okay, now we're just importing it into this file. What's actually happening is basically that we're importing it within this code, okay, within this function. Okay, now it's a bit hard to understand, but once you actually do this a bit, and then once you actually see me do the whole thing, you'll understand this better. Okay, so that's the setup code. Anything that you want to import, any function that you want to import, any library that you want to import, you include that in here. Okay, now the next thing is the test code. Okay, and by the way, these are just variables that I'm naming. Okay, it's just good for remembering. Okay, these can be anything. Okay, these can be called anything. We're just going to be passing these into the Timeit function later. Okay, now let's create a new multi-line string, and here we're going to create our testing code or the calling code. Okay, now imagine that this is our new program. Okay, we just imported the quicksort function, we just imported the randint function. So now what are we going to do? Okay, let's create an array first. Okay, now I'm going to create a for loop. Okay, imagine this is a completely new program. Okay, and let's do for x in range of sorry, wrong one. Okay, I meant actually 1000. Okay, I want to put 1000 numbers into this array. Okay, and array dot append a random number. Okay, sorry, randint. So basically what this does is that this for loop runs 1,000 times, okay, and it basically appends a random number from 1 to 1,000 into this array, okay. And finally what we want to do is pass this array into the quicksort function, okay, and this completes our calling code, right? So the next thing we need to do is actually call the Timeit library, okay. We need to use the Timeit function, because up till now we've just been creating variables and creating the test code and setup code, okay. We haven't actually been doing anything for the Timeit library, okay. So basically the Timeit library has two functions that we can use to actually measure the speed, okay, measure the performance. The first one is called Timeit, okay, it's the same as the library name, and the second is called repeat. Well, first I'll show you what Timeit does, and then I'll show you repeat later, okay. So basically I'm going to create this variable called time, okay, it's going to store the time, okay, for the execution time, okay, it'll store the execution time. And over here we'll create the function setup is equal to setup code, okay, and see these names actually help you understand what's going on. So the second one is called stmt, okay, this is where you pass the test code in. And the third parameter, okay, you don't have to include this third one, but I want to, because by default what Timeit does is that it runs this code, it's going to run this code 1 million times, okay, and then it will return us the time for the time taken to execute this code 1 million times, and I don't want that, okay, because this is sorting algorithms and this will take quite a while. So I'll just lower this down to maybe 100, okay, or let's just keep it at 10, okay. And then what I'll do here basically is print time taken, okay, and time. Hold on, there's some formatting over there, and there you go, okay. Now let's actually try running this just to see whether we did everything correctly, okay. Okay, slight problem there. Of course. It's better to just use the format function for this, but whatever. Okay, there you go. It took 0.04 seconds to execute the quicksort algorithm on 1,000 numbers 10 times. So the actual time taken for one algorithm completion was 0.004. Okay, so here we've gotten a good idea of how this works. Okay, we know that the quicksort algorithm is pretty fast. I mean, it sorted 1,000 numbers in just 0.004 seconds. That's really fast. Okay, now let's go ahead and do the exact same thing for the bubble sort algorithm. And before that, let me just mention that this was the quicksort algorithm over here. Okay, quicksort. Okay, let me just quickly copy paste this. Okay, it's mostly the same thing. Okay, and I'll call this one test2, and over here I'll do bubble sort. Okay, and let me just check the spelling once more. Okay, bubble sort. Yeah. Okay. Okay, back here, bubble sort. Okay, this remains the same, and this also remains the same mostly. Just change this over here. Okay, and let's change that over there, and we are done. Okay, now let's run both of them and see which one's faster. Okay, now look at that. Quicksort completed itself in, it completed 10 iterations in 0.04 seconds roughly, and bubble sort on the other hand took 1.14 or 1.15 approx. That's a big difference, and it's like 30-40 times more. Bubble sort took 30 or 40 times more than quicksort. Now that's a very significant difference, and I doubt you guys know too much about algorithms, but for those of you who do, basically bubble sort is basically a n-squared algorithm. Okay, it's basically a slow algorithm. Okay, and quicksort, as the name implies, is a pretty fast way of sorting, which is why it is astronomically faster than bubble sort. Okay, if you actually want to learn more about sorting algorithms and their performances and stuff like that, I'll actually include a link in the description below. Okay, And we also, there's actually a whole article I made on comparison of sorting algorithms where we actually use that Timeit library to measure them. Okay, we did that in a very detailed manner, so you might want to check that out. Okay, it's a very professional way of actually measuring the algorithms and their times. Okay, now back to this. This is one thing I want to mention. Okay, that's really crucial, and I think a lot of people will have trouble with this if they don't pay attention. Is that the indentation over here is very important. Now let's say, for instance, I messed that up. Okay, I put a space over there. Let me run this, and there you go. It's an indentation error. Why did this happen? It's because I told you to pretend like this is a separate program, right? So basically over here, imagine that if you did this normally in a program, right, this will cause problems, right? If you go around, making unnecessary indents in different places, that's going to cause problems. Okay. Now, if you did it over here, for instance, that doesn't make a difference, obviously. Okay, that works. But in places like over here or something, it basically confuses the Python interpreter. Okay, it makes it think that is that a new code block or something, or basically it gets confused. So basically, just a very easy way of remembering this is that do not leave any spaces in between. Like don't leave any spaces here. Okay, it should be basically hugging the wall. Okay, hugging the left side. Okay, no spaces unless where necessary. Right. So just keep that in mind. And besides this, let's go ahead and take a look at the repeat function. Okay, now this one is pretty interesting, and this is what I actually use when testing algorithms. Okay, when actually, when I want really accurate results. Basically, what repeat does is the same thing as Timeit, but the only difference is that it conducts a set of repetitions. It doesn't do it just once. Okay, it basically performs the entire test like as many times as you want it to. By default, the repeat parameter is 5. Okay, I'll just leave that over here. Okay, because 5 is perfectly fine. We don't need more than that, so I'll just leave it at 5. I'll just include that there so you can actually see it. Okay, and I'll include 5 over there as well. And basically, because this is basically a set of times, okay, it's no longer just one time. Okay, it's not going to return just an integer value or a float value. It's basically going to be returning a list of values. So let's call this times for one, and we can't just print this out like this anymore. Okay, let me just comment that out for now. Okay, I just want to show you something. Okay, I just want to do this print times. Okay. And over here, I'll do print times. Okay, now let me run this. Okay, now look at that. That's quite a bit of times over there. Only one of them seemed, oh, of course, bubble sort just took a long time. Hold on. Okay, so this is the quick sort times. Okay, we have 5 times in here. Okay, 1, 2, 3, 4, and 5. Okay, these are 5 times for the quick sort algorithm. And these are the 5 for the bubble sort algorithm. Okay, now let's take a look at these. Do we notice anything interesting? Well, something interesting I do notice is that in the bubble sort code, if you look over here, this first one takes 3.11 seconds, while the rest of them take on average 1.8. Yeah, 1.8 on average. So that's kind of weird, right? Like one of them is taking like so long and the others are just taking 1.8, right? That's almost double. So this is actually why we use the repeat. Because the thing is, when you're actually performing operations like this, when you're basically using testing code, sometimes the background programs from your computer can actually mess things up. Like sometimes maybe your computer is lagging a bit, or maybe something's going on, like some kind of background operation was happening at that time, which basically messed up your time. Okay, it basically took longer than it was supposed to. So basically, this is why we use repeat, because looking at this data, we can clearly tell that the actual time is more like 1.8. Okay, it's not 1.3. It's not 3. Okay, so yeah, that's why it's useful to use repeat. Okay, and another way of further increasing the accuracy is to basically use min. Okay, min over here like this. Okay, so why min and why not max? Okay, min and max are built-in functions. Okay, min returns the minimum value in a list, and max returns the maximum value in a list. So the reason we use minimum is because this is actually the more officially recommended thing. If you go to the official Timeit page, the documentation for the Timeit function, you'll actually see that they recommend minimum. Okay, because maximum is usually inaccurate because it's usually the iteration which was basically interfered with, okay, which was basically deliberately slowed down because of the background operations, okay. So that's why a minimum is more accurate, okay. That's why we use min and not max. Now let's run this, and okay, that's the minimum time for the quicksort algorithm. Now let's take a look at the one for bubble sort, 1.11. Okay, that's accurate enough. Okay, and yeah, there we go. This is basically, these results actually match the ones we were using previously, right? With the Timeit function. If you remember, we had like 0.04 and 1.3 something, I think. Or 1.15, yeah. And these are basically matching those. So we know we're basically doing this correct. So yeah, that's it. And this is how you use the Timeit function, the Timeit library. This is how you basically take advantage of sorting algorithms and actually how to test them, okay? You can use this format for basically anything, okay? Any piece of code that you want to test how fast it's really going. Okay, so that's it for now. If you want to see more content like this in the future, make sure to subscribe. Otherwise, I'll see you in a later video.